Okay, so let's define repeated games a little more formally now. And the first ingredient of a repeated game is going to be the stage game. So we have these periods that are happening over time, so a finite set of, possibly infinite set of times. And each period we're going to have what's called the stage game. And we'll think of these as normal form games for now. So we just have our usual normal form definitions. We've got a set of players, 1 through n. We have a set of actions, pure actions or strategies for each player. We have profiles of strategies that we'll keep track of, and players will get some payoff as a function of what happens in the stage game. So the stage game here is what's being played each period, and we'll keep track of periods t. So t will be in a set 1, 2, 3, etc. Right. So we've got periods coming along, and then we can keep track of what was the action played by player I in time t, and we can keep track of as well what was the full set of actions played by all the players. So we have a list of what each player played at time t. Okay. So what's a history in this? So once we get to some time, we have to keep track then of what's happened all the way up to that period. So if we want to have a list of what happened in the first t periods, then that list ht is just a list of all the profiles. Remember that at is equal to a1t, etc. through ant. So this is a list of what everybody did in period t, what everybody did in period t minus 1, everybody did all the way back to the first period. Okay. So that's a history. A given history is a list of actions played, and then we'll let the set be denoted by h super t. That's the set of all possible histories of length t. And if we want to keep track of all possible histories, then we just take the union over all t's of the histories up through time t. So the set of all possible finite histories is just the union over all t's of these ht's. Okay, so what's a strategy in this setting? A strategy now is a mapping from these histories, the set of all finite histories, into possibly mixed strategies. So we'll allow people to randomize if they want. So a strategy now takes histories into mixed strategies in a given period. So for instance, SI of some history through time t specifies what person I will do, what player I will do after a history ht. So this is specifying what they're going to do in the t+1 period of the game. Okay, so for instance, with our prisoner's dilemma, we have a normal form game where we have the set of players 1, 2, the action sets cooperate or defect, and the corresponding utilities, so the UIs specified as a function of cooperate and defect given in the usual matrix. Now, in terms of the histories, if we think about all the possible histories up through time 1, so what could have happened in the first period? Well, one history is that both players cooperated. One history could be that the first player cooperated, the second player defected, and so forth, right? They could have both defected, etc., etc. When we get to histories of length 2, then a history of length 2 is going to be a specification of what happened in the first period and what happened in the second period. So if all players cooperated in both periods, then we'd end up with this history. If they both cooperated in the first period, but then the second player decided to defect in the second period, we'd end up with this history, and so forth. So each one of these is a different possible history, and you can go through, and you can begin to see that the number of histories is growing up very rapidly, so it's going to explode exponentially over time. So we're going to end up with strategies having to be dependent on the full list of everything that could have happened, or everything that did happen up through time t. Right? So strategies are listed for every possible history, and it's important, it's very important, that even though some histories don't happen, right? So suppose we end up cooperating in the first period, it's still important to know what would have happened if a player had defected. So how would they have reacted if you change your action. So in understanding repeated games, one thing that's going to be very important for players to do is have predictions of what will happen if you choose an alternative strategy. So one might be an equilibrium, but in order to figure out if it is an equilibrium, you have to do the counterfactual of what would have happened had I changed my action. And that might have led to a very different set of reactions by other players. So histories that are off the equilibrium path, is the usual terminology, are still going to be very important into knowing what will the other player do if I do this, if I do that, and so forth. Okay, so with strategies in hand and the basic definitions, then we can begin to talk about payoffs in these games. And that'll allow us to talk about equilibrium as well.